We'll just continue our discussion of combining functions with arithmetic. So in this video, we're going to look at arithmetically combining function equations. Okay, so this is probably one of the most prevalent applications of function arithmetic, and we're going to focus on some of the types of examples you might struggle with the most. I'll try to pick the ones I can think of, but you really do need to have a strong Algebra 2 or intermediate algebra background to understand all the intricacies of the algebra that could occur here. But again, I'll try to hit the highlights. So we're going to work through this as an example. So let's suppose that we have the function f of x, which equals 4 over x minus 3, and we have the function g of x, which equals the square root of x minus 1. So I find that college algebra students typically struggle with rational functions and root functions maybe more than others. So we'll focus in on those two. So we're going to work on some different arithmetic combinations of these two functions, and also we're going to look at the domains of those because that's a really big topic as well. So let's start by doing this. Let's determine f plus g and its domain. Determine f plus g and its domain. So what that means when we say determine f plus g, in this case, since these are both equations, they mean tell me the equation for f plus g as well. It's likely that if these were graphs, then the answer here should be a graph. But we're working with equations. So what we're trying to do is we're trying to figure out the formula or the equation for f plus g of x. All right, and we know that f plus g of x is defined to be f of x plus g of x. Of course it is, that's no problem. And then all we do here is we have to figure out what f of x is, which f of x is this fraction, 4 over x minus 3, plus g of x is this square root. And that is literally the formula for calculating the outputs of the function f plus g. No problem. That's the first part of the question. Now, we don't need to do any simplifying here. If we wanted to, we could make this square root into a fraction by putting it over 1. You can always turn something into a fraction by putting it over 1 and then getting a common denominator and putting those together. I don't see any need for that here. Now, the domain, when we find the domain of this, you always want to use the form before it's simplified, because before you simplify, you can see all of the critical areas of the function. Sometimes when you simplify, some of those critical areas disappear, and we'll see that later on. But here, we didn't need to simplify anyway, so we're going to find our domain right there. Okay, so let's work on domain. If we want to find the domain, we need the critical areas, which are denominators and what's under even roots. So I'm going to set those equal to 0 and solve to get our critical values. So those are the critical values, okay? X equals 3 and x equals 1. Should be familiar with domain already, so I'm going through this a little bit quickly, but no big deal. We got our critical values. We cut our number line at those values 1 and 3. And we start dissecting which parts of the number line, which x values on this number line will work in this function. And we can see that if x is 3, this denominator is 0, and we can't divide by 0. So we're going to leave 3 out of our domain because he causes us to divide by 0. If x is 1, 1 is fine in the fraction. It doesn't make the denominator 0. 1 is also fine here because 1 minus 1 is 0, and we can take the square root of 0. So 1 is in our domain. Okay? Now, to make sure that, so the only other, we've taken care of everything that causes a problem with our fraction. Everything else on our number line works in the fraction. But for this guy, we have to have numbers bigger than 1 so that we make sure we have a square root of a positive. So now we're going to shade everything bigger than 1 except for 3. 3 doesn't work, as we've already said. And numbers smaller than 1, like 0, for example, will give us a square root of a negative if we plug them in for x. So I'm leaving this region out because I get a square root of a negative. And so our domain is the union of these two intervals. Okay, so we have our function, we have our domain now. Again, what was nice about this was our function didn't simplify, so it made it a bit easier to find our domain. All right, let's do the same thing, but now let's do f over g and its domain. We'll determine f over g and its domain. We'll run through the same process. Determine f over g and its domain. So same idea, we need the equation for f over g of x. So we start f over g of x is equal to f of x divided by g of x, which is the fraction, f of x is the fraction, divided by g of x, which is the square root. Okay? And so we're going to do the domain of this. This is the step where we are going to find our domain. This is the step before we do any simplifying. Okay, so keep that in mind. But we need to go ahead and simplify this complex fraction now to get our function, to get the formula for our function. So anytime I want to divide a fraction by something, that's the same thing as taking whatever's on the top, in this case the fraction, times the reciprocal of whatever's on the bottom, which instead of the square root of x minus 1, it's 1 over that. And now we can just multiply straight across. See if that fits on the screen. Yeah, it does. So on top we have 4, and on the bottom we have x minus 3 times the square root of x minus 1. And so that's the formula for f over g of x. We could leave it like that. Now when we want our domain, again, we need to look at this unsimplified version here. And we need to analyze our critical areas again. Well, our critical areas are denominators. That's x minus 3. That's also the square root of x minus 1. Both of those are denominators. And then, of course, anything under an even root, that's x minus 1. But if we set that equal to 0, we're going to get the same thing as if we set the square root of x minus 1 equal to 0. So we don't really need to do that. I'll write it here, and I'll cross it off because it's going to give us the same answer as this guy. So now if we solve these for x, we get x equals 3. If we square both sides to get rid of the square root, we get x minus 1 equals 0, and then we add 1. So we have our critical values, which are the same. Do not assume that the domain will be the same, okay? That's a common mistake. So now, if we look at x equals 1, that will not work as an input because it will make this denominator 0. So now 1 is not a valid input. 3 makes this denominator equal to 0. It is also not a valid input. And then because of the square root, we have to pick values bigger than x equals 1 because numbers smaller than 1 will give us a square root of a negative. So now our domain changed slightly. It's everything between 1 and 3, union everything from 3 to infinity. But this time 1 is not included in our domain. So exact same concept as before, it's just that now the function's simplified. It actually ended up giving us a complex fraction, which is one of the things I wanted to mention in this video because I know students often struggle with that. All right, let's continue along these lines. Now we're going to do f times g. Same instructions, but with f times g. All right, so determine fg of x and its domain. And you could also put f dot g, f times g of x. They're the same thing. But I should word it the same, right? Usually it's not worded as determine fg of x. It could be. It's typically just worded as determine fg. Determine fg and its domain. So lots of ways to ask this question. But again, we know that when it's written like this, it's asking for an equation because the two functions are equations themselves. So we start by knowing that we need the formula for fg of x, which is the same thing as f of x times g of x, which is the f fraction times the g square root. And this is the step before we simplify. So that's where we're going to come back and find our domain. We'll do that in a minute. But this is so easy to simplify because all we have to do is turn this into a fraction by putting it over 1, because we're multiplying, and we just multiply straight across. So this simplifies to be 4 times the square root of x minus 1 over x minus 3. Okay? And that's simplified enough. But when we look at domain, let's look at this step here. And we identify our critical areas, which are denominators, this guy. We don't have to worry about 1 as a denominator because there's no variable. It's never going to equal 0, right? And the other critical area is x minus 1, and that's because it's under a square root. So again, you see, we get the same critical values, x equals 3 and x equals 1. The number line cuts the same way. And now, x can be 1 because a numerator, which is where the square root is, can be 0. So that's fine. X cannot be 3 because we'd be dividing by 0, right? And then because of the square root, we have to pick x values bigger than 1, but not equal to 3. And then numbers over here, smaller than 1, will give us a square root under the negative. So our domain is the same as what we had in that first example, including 1 again, because this x minus 1 was not in the denominator, okay? So no problem. Let's throw a little kink in things now, and let's work with FF. Let's not even involve G in the next example. Let's look at FF. So let's determine FF and its domain, which of course means F times F. So we're looking at FF of x, which is the same thing as f of x times f of x, which is the fraction times itself. And this is the step we'll use to find our domain. But to multiply these is really simple. You just go straight across and get 16. And on the bottom, we have x minus 3 squared. If you want to multiply that out, you can, but this is just fine. So that's the function. This is the step where we will find our domain. And the only critical area here we have are the denominators, x minus 3. It's the same in both cases, so we can tell that x equals 3 is our only critical value. 1 is not involved anymore. We cut our number line at the critical value, and clearly x can't be 3 because we'd be dividing by 0, but x can be anything else because nothing else will make the denominators 0. So the domain of this function is negative infinity to 3, union 3 to infinity. Okay? A little bit simpler than the others, but sometimes when you use the same function twice, maybe that's confusing, all right? And maybe you can guess what the last example is going to be. Let's look at g times g. So determine gg and its domain. So we're looking at gg, which is g times g of x, which is defined as g of x times g of x, which is the square root of x minus 1 times itself. And this is the step we'll use to find our domain. But let's go ahead and simplify. The square root of x minus 1 times the square root of x minus 1 is the square root of x minus 1 squared. Since they're both square roots, we can actually multiply the x minus 1s together to get x minus 1 squared. And the cool part about this is when you square root a square, they cancel and you just get x minus 1. Okay? So that's the simplified version of this function. So it's really interesting that gg of x is this, but it simplifies to x minus 1. And if you look at this, if you looked at this for your domain, you would say, well, there's no critical areas, there's no denominators, there's no even roots. So the domain would be all real numbers if you are based on this for your domain. But in reality, if you want to calculate this, you have to calculate this square root first and then multiply it by this square root. And you can see that there are square roots involved in getting to this point. So it's important that you use the unsimplified version of the function to calculate domain. And so of course, x minus 1 lives under a square root. So x equals 1 is our critical value. And we cut our number line there. And x can be 1 because if you plug it in, you get 0 and you can take the square root of 0 with no problem. That's just fine. But if you choose a number for x that's less than 1, as we've said many times before, you get a square root of a negative. So we throw that region out and everything over here gives us a positive under the square root, making our domain 1 to infinity, including the 1. All right, so that's kind of a rapid fire of arithmetic of function equations. And it's really not that bad. If you've got a good understanding of basic and intermediate algebra, the simplifying won't be a problem. If you've got a good understanding of domain, the domain won't be a problem as long as you look at the unsimplified version of the function.